So if we wanted to give a definition for a function using words, what would it be? Or how is a function different from other types of equations? What do you think?
It's sort of like a key, like a thing that you use to solve multiple stuff.
Okay.
Is it a binary relation between two sets that associates each element of the first set to exactly one element of the second set?
So how would we say that in our own words? So I agree, it is a relation. It does have an input and an output. I like those words. So a relation between two sets. Okay? But is there anything special that has to happen between the inputs and the outputs? So what do we usually call our input values? X. So where each x value is paired with what? It is paired with a y value. But how many y values? Can it be more than one? Nope, it doesn't depend on the thing. Correct. If it's paired with more than one y value, it is no longer a function. So, one x value has to be paired with exactly one y value. Do we recall what test a graph would have to pass in order to tell if it's a function or not? The vertical line test. So if I have something that looks like that, or if I have something that looks like that, remember that we can think about it like drawing a bunch of vertical lines through each of our graphs. And if any vertical line passes through more than one point, it is not a function. So would this first one be a function? Yes. Would this second one be a function? No. Are we all okay with that? Now, what are the different ways that we can represent a function? I gave you one of them. A graph. What else? A table. What else? An equation, so using algebra. And the last one, this is the one that y'all tend to not like as much. So verbally, so like word problems, me describing it to you with words. And we'll look at different problems using different representations, and sometimes we'll have to flip back and forth between the representations. We'll have to take a graph and make an equation, or take an equation and make a table. We're just going to depend. Questions on that? So let's look at some examples and decide if it is a function or not. So these are three separate problems. Okay, so these aren't all the same thing. Three separate problems. Are y'all with me? So on our first one, it's given to us verbally, and it says the input value x is the number of representatives from a state, and the output value y is the number of senators. So we're going to have to use a little bit of our U.S. history knowledge. Okay, so how many representatives does each state have? It is not two. Yes, what is it?
It depends on the population.
It's based upon your population. So, how many senators does each state have? They have 2 senators. Are we all with me? You'll vaguely recall that, hopefully, from one of our history or government classes?
No.
Your U.S. history teachers are crying on the inside. All right, so let's think for us, would this this represents a function. If my x values are the different values that I get based upon their population, so 25, 50, 122, whatever they may be, and all of my outputs are 2, is that going to be a function? Yes.
Yes.
What would our graph look like? What kind of line? A horizontal line. Is it going to be connected? No, it's going to be what we call discrete, meaning they're just a bunch of dots. So it looks like that. Because my representative number is going to be different, but then the senator number is going to be the same. Now, what about if I flipped those? And I said that my x value is my number of senators, and my y value is my number of representatives. Would that be a function? No, because what type of graph would we get? A vertical line. And a vertical line doesn't pass my vertical line test. Alright? Now, what about our second one on part B? This time they give me a table. Is that one a function?
No.
No, what's the issue?
2 and 2 equal different things.
My two 2's have 2 different y values, so that would be a no. What about my third one? Yep, I don't have any points that are stacked on top of each other, so it would pass my vertical line test. And our last representation is algebraically, okay, so using functions. Now, when we're looking at functions of y in terms of x, how do we usually put those? Like, what's the standard way to look at them? So, like, what is our point or our slope line form?
That's y equals
Mx plus b. So what's the important part there at the beginning?
y.
Y equals stuff, right? So when we're looking at things with functions of y, we usually want y to be by itself. On either one of these is y by itself. No, so we need to solve for some stuff. So how would I solve my first one for y?
Subtract x squared on both sides.
Agreed. So then remember that we need to think, okay, if I plug in a number, so let's say 2, what would I get out? Be careful. Be careful. So 2 squared is 4. Then I stick a negative on the front of it, because the negative is not included inside of my head. So we would get negative 3. There we go. Is there another way for me to get an additional output for the same input? So I still plug in 2, but I get out a different number using correct math skills. Yes? No? No? I don't think so. Okay, what would we get if we plugged in, say, negative 2? It would be the same thing, because we would have to do our exponent first, so negative 2 squared is still 4. Then we stick our negative in the front, plus 1 still gives us negative 3. Now, is it okay for my y values to repeat themselves? Yeah, but we just can't have an x value that has more than one output. So, in this case, what is our answer? Is it a function or not? Yeah, if we wanted to look at the graph, because sometimes that's helpful, what would this graph look like? It is going to be a downward parabola. What does the plus 1 do?
It raises it to the center at one, the vertex at one.
Agreed. So we'd look like that. Does that graph pass our vertical line test? Yeah, so we're good to go. Now, what do we need to do on our second one to solve for y? Add x to both sides, and then square root it, so we get y equals, okay, we're missing something, plus or minus. So when I take the square root of both sides, we have to add a plus or minus to the front. So now, let's say if I plugged in 3, what would we get out?
Negative 2.
so we would have 3 plus 1 gives us 4. The square root of 4 is 2. But then we have this plus or this minus. So how many y values do we have for our 1x value? We have 2. Is that okay?
Nope.
No. So is this a function?
No.
No. What would this graph look like? So what do our radical graphs look like? Do you remember? It kind of looks like a half of a sideways parabola. And my plus 1 is going to move it to the left. Okay? So that would be my top half. That's the positive one. But my negative has reflected it. So your graph would look like that.
Oh.
Does that pass my vertical line test?
No.
No. So, makes sense. We got no there. Question on either one of those. Yes. Can you just go back real quick? That looks fine. Okay, good now. So, whether I give it to you as a table, as words, as an equation, or as a graph, we need to be able to tell me, is this a function or not? Alright, so now let's remind ourselves of some different things that we can do with functions. Our first is going to be evaluating a function. So remember, we evaluate a function by plugging in a value, whether that be an actual number, a variable, or an expression. So like on our first one, what are we going to do with the 2?
Replace it with X.
Not replace it with x,
Or with X.
but replace the x with the 2, right? So we're going to plug a 2 in to every place that we have an x. And what do we get? So 2 squared gives us 4, negative 4 plus 8 gives us 4, plus 1 gives us 5. Alright, now what about on part B? What am I replacing my x with this time? I'm replacing it with a t. So I'm just putting in a different variable this time. Now, do I have anything that simplifies there? No, if we don't have anything that simplifies, then that's going to be our answer. Is it okay that we have variables in our answer? Yeah, sometimes we'll have answers with variables in it, and that's all right. Now, what about on our last one? We have g of x plus 2. So this time I'm replacing my x's with an x plus 2. So I have negative x plus 2 squared plus 4 times x plus 2 plus 1. Now, be careful, because how do I square a binomial? We have to FOIL or multiply it out. Remember that x plus 2 squared is the same thing as x plus 2 times x plus 2. We cannot just distribute our squared if we have pluses or minuses. And I saw several people try and do that on your test. So just be careful with that, okay? So what do we get when we multiply the x plus 2 times x plus 2 out?
X squared.
Plus
4x.
4x plus 4. And then we can distribute our 4, so we get 4x plus 8. And then the plus 1 is still just hanging out. Then we distribute our negative. Plus 4x plus 9. So then our last step, we get negative x squared plus 5. Questions on that? need to be able to find when a function is equal to 0. If I'm finding when a function is equal to 0, what are we finding, or what are they called? The zeros are also called the roots, are also called the, erase that one. If I'm looking at a graph, when does
The origin.
f of x equal 0? Or when do our y values equal 0? So I have y values, right? What spot do my y values equal 0? Different word. The x-axis, which would be our x-intercepts, right? So we're finding our x-intercepts here. So roots, zeros, x-intercepts, they all mean the same thing. So for this one, what would we do in order to solve for x? Subtract 10, and then divide by negative 2, and we get 5. Pretty straightforward. What's different about our next one? There's an x squared, which means it's a quadratic, right? So how do we solve quadratics? You could use the formula, but we usually want to try and factor it first, okay? If I see a quadratic, my first goal should always be to factor it. So in this case, if I use the AC method, what multiplies together to give me 6, that adds together to give me negative 5. Agreed. And then once I have it factored, what do I do with the factors? Set them equal to 0. So what do we get as our answers? 3 and 2. So how many times does that graph cross the x-axis? 5. Okay. Questions on either one of those? Yes? No? Maybe? Okay. So again, we're just kind of trying to remind ourselves of different things that we can do with functions. Sometimes we need to know where two functions equal each other. So if they give me an f of x and a g of x, and they ask us where those two things equal each other, what would we do? Just set them equal to each other and then solve. So in this case, we have x squared plus 1 equals 3x minus x squared. So what type of function are we going to have? If I have a squared, what type of function is it? A quadratic. And what did we say our goal is to do when we have quadratics? Factor. But what do we have to do before we could factor this? We can't combine. We don't have any like terms right now on the same side. We can't. None of what? Get them all together. Where? One side. Yeah, it doesn't matter which side, but they have to all be together before we can start doing anything with them. So I would add my 2x squared, or my x squared over and get 2x squared. I would subtract my 3x. And now we have a trinomial. So can we factor that? We should be able to factor that. We did that on our last quiz. So remember, I'm looking at what multiplies together to give me 2 times 1, which is 2. That adds together to give me negative 3. Negative 2 and negative 1. Now, what do I do with those two numbers? Yes, replace the negative 3. So I'd have minus 2x minus x plus 1. And then what do we do? Factor by grouping. So if we're still struggling with the factoring part, we really need to make sure that we're making time to come in and get help, because now we need to be able to use the factoring to solve for other things. So then I can set my factors equal to 0. And we get x equals 1 and 1/2. Okay? I want you to try the next one on your own. The same type of problem. I'm figuring out where does f of x equal g of x. Alright, so remember that our first goal is going to be to get everything to the same side, because that's what's going to allow me to factor. So this time we would have what multiplies together to give me -6, that adds together to give me -1. So that would be a positive 2x and a -3x. So again, factoring by grouping. So that should be what we get if we factor it. Do you have any questions on the factoring stuff? So then we can set our two factors equal to 0. And we should get x equals -1 and x equals positive 3/2. So these graphs would intersect each other at two different points.
How do we the opposite? The other side.
That's fine. You would still get the same answer. Yep, doesn't matter. Your factors would just be like some of your negatives would be.
-2x
Yep.
plus 6x.
How would you know that?
How would I know what?
How many times that?
Because I have two x values.
Oh.
So here, if we only got one x value, then they would only intersect one time. I get two x values, then they would intersect each other two times. You got more, then however many more you got. Okay. So let's look at our last type of example, which is reminding ourselves about domain. So on part A, our first question, they just give us a list of points. Remind me, which value is my domain value? The x value. Yep. So if they just give me a list of points, my domain is just going to be what all my x values are. I'm just going to list those all out. So I have -3, -1, 0, 2, and 4. So if it's just a list of points, then my domain is just a list of values. Now on part B, okay, we have a function this time. So normally, remember, if our function does not have any restrictions, our domain is just auto numbers. But if I have a fraction, are there any numbers that might cause issues plugging in for my second function here? What would they be? What number would I not be allowed to plug in there? Why? Yeah, then I would have 1 over 0 on the bottom. So notice that x cannot equal -5. So we have two different ways to write this. The first is our set builder notation. So I would say x such that x cannot equal -5. Okay. The second way is our interval notation. So remember, that's the one with like the parentheses and the brackets. So remember that if it's parentheses, it means does not equal. So basically I'm saying that it's everything before -5. Because it's a parentheses, I'm not including -5. The union basically stands for like and, like I'm putting them together. And then it's everything after -5. So item notation is fine. Alrighty, what about for part C? I have the volume of a sphere. So are there any numbers that I'm not allowed to cube? That's all that's happening here. Does cubing something cause restrictions, like my dividing did? No, it doesn't. But we have to think about the context of this. If I'm talking about a volume, that means that R represents our radius. So what does our radius have to be? Positive, but also what? So So that means it has to be greater than 0. Can it be equal to 0? No, because then we wouldn't have a sphere. Okay? So this one, if we wanted to use our interval notation, we would have 0 to infinity. Now, for our last one, we have a radical this time. What causes issues for radicals?
The plus and minus.
Kind of. Negatives underneath our radicals. So we would have to figure out what's going to make this negative. So we would subtract 4, divide by a negative, but then we have to flip our sign, right? Agreed? So then again, we could write this using either of our notations. X such that x is greater than or equal to 4/3. Okay, or in our set builder this time, it would be